8 minutes, 24 seconds. That's the answer to the question in the title of this video, and it was in the thumbnail. So I'm not trying to just trick you to watch this video of literal water boiling for the whole time to get the answer. But if you stick around, there's a lot more to it than just that number, and I think you might learn some interesting things about induction cooking. So to start with, I boiled 4 liters of water. You saw me pouring that in there. Oh, and by the way, my name is Steve. I also host a podcast about plants called Rootbound. Find it wherever you get your podcasts, but this is not about plants. It's about induction cooking. So to start with, I measured the temperature of the water just to show that I'm not cheating, and that's also going to be helpful later. So the temperature of the water starting out was 18.9 degrees Celsius. I'm using the metric system because that's just better for all the scientific stuff. I like it better. You can convert to Fahrenheit on your own. And here we go. I'm going to start the timer and turn on the stove at the same time. It's on maximum output on the most powerful burner. And we are starting to boil water. Isn't that exciting? I was inspired to make this video by Alec of the channel Technology Connections, who did a similar video comparing gas and traditional resistive electric. And I thought it'd be interesting to do a similar video with induction because I just got this interesting induction stove. By the way, this is a cafe double oven induction stove, a 30-inch slide-in. It's pretty cool. And I thought I would just show you that even here, just like over 30 seconds, there's already bubbles forming. So I'm cutting in the video from my cell phone here just real quick, just so you can see there's already action. You can already see that the heat is taking place, which is really amazing. So if you haven't guessed, induction is very fast at boiling water. I mean, 8 minutes and 24 seconds is fast, particularly in comparison to other things. So in the Technology Connections video, Alec boiled 4 quarts of water on both his old gas stove and his new resistive electric stove, the traditional electric stove. And I boiled 4 liters, so there's a little bit of difference there. 4 quarts is 1 gallon, which is 3.785 liters. And so I heated about 5% more water than he did. So we can do some conversions to make it a little bit more fair later. But his observation was on his old gas stove on the biggest, most powerful super power boil burner. It took 16 minutes and 47 seconds to get the water to boil, and on his new electric on the biggest, baddest burner, it took 18 minutes. Converting for the extra 5% time, because I heated 5% more water than he did, that would be the equivalent of 17 minutes and 37 seconds on the gas superpower burner and 18 minutes and 54 seconds on the electric super burner. So my induction stove at 8 minutes and 24 seconds is over twice as fast as the gas on the super powerful burner, which is interesting. Just to note here, about every 2 minutes, I'm putting the temperature probe in just so we can see how the temperature goes up. So right now it's about 40 degrees Celsius. So it's gone up about double since we looked at it, which is pretty cool. So yeah, basically twice as fast to boil water on an induction stove that is, unlike the most powerful gas stove, at least that Alec had. When it comes to the electric stove, it's pretty interesting that the electric was slower than the gas. And if you watch Alec's video, you should check it out because it's really only in this one circumstance, which is the most powerful super gas burner that uses a ton of gas to burn, where it beat the traditional electric. In his video, he shows that on all the rest of the burners, the electric is actually better than the gas. So I just wanted to point that out. But induction electric is just way better. At 8 minutes and 24 seconds, it's over twice as fast. And there's some things I'll talk about later that maybe there's some ways that could be even faster. So, why did I get an induction stove? Well, first of all, they're just better in every way, and I've been using it and just been really enjoying it. It is way superior to the gas stove I had before in every way. So that was one reason. 2 is my wife and I just had a kid, and there is this real thing of indoor air quality with gas stoves. You are burning combustion fuel indoors without proper ventilation, and even if you have a good hood, it's not like a car where the combustion happens isolated from you and then is piped outside. That combustion is happening in the same air that you breathe. And there's a lot of studies that show that's not really great. Also, I'm an environmentalist. I don't want to keep burning fossil fuels when I don't need to. And yes, I know that the electricity in my house is most likely coming from fossil fuels, but the induction stove is just so much more efficient. It doesn't even matter. And plus, we're moving to more and more renewables anyway. And also, I plan to get solar panels someday. So it's just better for the environment and better for indoor air quality in every way. And 3, and probably the most obvious one, I wanted to do this for a while, but we were just doing a remodel that had us opening up the wall on the other side of the induction stove for a bathroom remodel, and it was a perfect time to install the 40 amp circuit necessary to run the induction stove. And that comes to the 2 caveats for why I think someone shouldn't choose an induction stove if you're getting a new stove. I mean, if you have a stove already, like, use it. We don't want to be wasteful. But if you're deciding on a new stove, I think induction is the way to go, like, hands down. But there are 2 caveats for why maybe you wouldn't get it. The big one is power source. To get an induction stove, you have to put a 40 amp circuit in. And if you have a regular gas stove, you probably just have a normal plug back there. And that's not necessarily an easy thing to do, depending on your house. It's not necessarily cheap. There has to be electrical work done. And in my case, the walls were being opened up anyway. It was just super convenient to put in the new circuit there, so that was no problem. The other caveat for why you wouldn't choose an induction stove is if you have like a ton of really good cookware that is not ferromagnetic, because if you don't know, the one catch with induction is you need to use a pot that is magnetic, that you can stick a magnet to the bottom, or else the induction won't work, because induction uses these electromagnetics to induce heat in the cookware itself. And it won't work if you're using aluminum pans, if you're using copper pans, anything that doesn't, have a magnet stick to it, it won't work. So if you got some really nice pans that you really love to use, then maybe you don't want an induction. But there's some other workarounds that maybe I'll talk about in another video of why it's still probably not worth it. I've been using cast iron, and I've been using stainless steel for a long time, so that wasn't a problem for me. Just about to hit 80 degrees. Look at that. Okay, I gotta speed up here to get through the math part of this situation. So, one thing that's really interesting about heating water is it's heating water, and heat is heat, and water is something that Alex said in his video, and it's very true. So we can do a little bit of math to see how much energy we put into the water and how many watts were used. So we're using this heat equation, which is Q equals mc delta T. The Q is the heat put into it, and that is mass times the specific heat of the substance. So in this case, water, the specific heat of water is 4.186 joules per gram degrees centigrade times the change in temperature. So in this case, it's 4,000 grams times 4.186 joules per gram degrees centigrade times 81.1 degrees Celsius, which is how much we raised from 18.9 degrees Celsius, you remember back at the beginning, to 100 degrees, which is boiling. And that gives us about 1.3 million joules. And if you divide that by the time, which was 504 seconds, we get 2,693.25 watts. That's what we were using there. Now, this is pretty interesting because this burner is supposedly 3,700 watts. And it would have actually been almost about 6 minutes if we were really putting 3,700 watts directly into it. But there's a few reasons why we wouldn't get that full 3,700 watts. One is just general losses. No system like this is perfect. You're going to lose some stuff. Also, maybe this pot is not really the best pot. Maybe it is not fully magnetic on the bottom or something. I don't know. It's an old, cheap pot. 2, as we're heating, heat is still escaping. So it's not a closed system. We're always losing heat, so it's not perfect. We're putting heat into it, but heat is also escaping all the time, so we're going to lose some stuff there for inefficiency. And then finally, there's a line in the manual for the stove that says, if a surface unit is on power level high for an extended period of time, or if multiple surfaces are on, there may be a slight reduction in the power to the surface unit. Also, water under the pans may cause the controls to reduce the power delivered to the cookware. I don't think there was water under this, but maybe it was on so long that it did it. Okay, we're getting to the exciting part. It's about to hit 100 degrees here. I'm going not by where the water looks, but by the temperature gauge, which is a little bit hard to read, but there it is, 8 minutes and 24 seconds. We have achieved boiling. Thank you for watching this pot boil with me. And now I'm going to do something that is not advisable even on an induction stove, but is definitely not advisable on any other stove, gas or traditional resistive electric. I'm going to move the pot to the side here in a second, and I'm going to touch the surface because the surface doesn't get hot. The surface only gets hot from the bottom of the pan. So it's still hot, and I can't really leave my hand there, but it's not scalding like any other stove, which is pretty cool. And just in general, the lack of heat in the room from induction is a really great positive. Anyway, I'm going to probably do more of these induction videos if you like them, but that is how long it takes an induction stove, at least mine, to boil 4 liters of water.